Sound waves. Like other waves, sound is also produced by vibrating body. Due to vibration of bodies, the air around them also vibrates, and the air vibration produce sensation of sound in our ear. For example, in a guitar, sound is produced due to the vibration of a string. Our voice results from the vibration of our vocal cords. Human heartbeats and vibration of other organ like lungs also produce such waves. Doctor use stethoscope to hear these sounds. Sound is produced by a vibrating body. In school laboratory, we use a device called tuning fork to produce a particular sound. If we strike the tuning fork against a rubber hammer, the tuning fork will begin to vibrate. We can hear the sound produced by tuning fork by bringing it near our ear. We can also feel the vibration by slightly touching one of the prongs of the vibrating tuning fork with the plastic bar suspended from a thread. Touch the ball gently with the prong of a vibrating tuning fork. The tuning fork will push the ball because of its vibration. Now, if we dip the vibrating tuning fork into a glass of water, we will see a splash. What does make the water splash? From this activity, we can conclude the sound is produced by vibrating body. Sound required material medium for its propagation. Unlike light waves, which are electromagnetic in nature and can also pass through vacuum, and sound waves require some material medium for their propagation. This can be proved by bell jar apparatus. The bell jar is placed on the platform of the vacuum pump. An electric bell is suspended in the bell jar with the help of two wires connected to a power supply. By switching on the power supply, electric bell will begin to ring. We can hear the sound of the bell. Now start pumping out air from the jar by means of vacuum pump. The sound of the bell starts becoming more and more feeble and eventually dies out. Although bell is still ringing, when we put the air back into the jar, we can hear the sound of the bell again. For example, from this activity, we conclude that sound waves can only travel propagate in the presence of air or another medium. Propagation logic, login longitudinal nature of waves. Propagation of sound waves produced by a vibrating tuning fork can be understood. Before the vibration of tuning fork, density of air molecules on the right side is uniform. When the right prong of the tuning fork moves from the mean position O to B, it exerts some pressure on the adjacent layer of the air molecule, produce a compression. The compressed air layer in turn compresses the layer next to it, and so on. A moment later, the prongs begin to move from B towards A. Now the pressure in the adjacent layer decreases, and a refraction is produced. This fraction is transferred to the air layer next to it, and so on. As the tuning fork moves back and forth rapidly, and a series of compression and rarefaction are created in the air. In this way, sound wave propagates through the air. The direction of propagation of sound waves is along the directions of oscillation air molecules. This shows the longitudinal nature of the sound waves. Distance between two consecutive compression or refraction in the wavelength of sound wave.